Hello, dear students. Today we are going to learn the concept of mole. In earlier lectures, we have learned what is basics of chemistry, what is atoms, what is molecules, what are compounds, difference between these atoms, molecules, and compounds. We have also defined mass of atom, mass of molecule, different types of masses used in chemistry, and the relationship between the various masses. Now the question arises, though we have defined atoms, molecules, compounds, and we also calculated their masses by use of different techniques, different units. But the question is how to find or how to count the number of atoms, the number of molecules, and the number of compounds which cannot be observed with naked eyes. These atoms, molecules, and compounds being very, very small, which cannot be observed with naked eyes, how to count them? So, to solve this problem of counting these very small particles which cannot be observed with naked eyes, we have developed a concept which is known as mole concept. So, basically, the concept of mole is to define the amount of substance which cannot be observed with naked eyes. We cannot use this. We never use or we don't use the concept of mole for counting objects which can be seen with naked eyes. These are basically mean for those atoms, molecules, electrons, protons, neutrons, and those particles or subatomic particles which cannot be observed with naked eyes. So we have a term that is mole. So mole is a unit which is used for measuring the amount of chemical substance. Used for measuring the amount of chemical substance. So when I use the term chemical substance, these chemical substance like atoms, molecules, compounds, electrons, protons, nucleons, neutrons, ions, etc. Atoms, molecules, compounds, ions, or subatomic particles. These chemical substances are measured by use of this mole. So basically mole is basically mean for measuring chemical substance. Then the question is how to define this term mole and what is the significance of mole. Now this mole has its relationship with atomic mass measured in terms of carbon scale. When we measure mass of the substance in carbon scale, we take the help of the most stable isotope of carbon, that is carbon 12. And while discussing different types of scales used in atomic mass measurement, we have seen or we have learned that the most standard reference uses carbon 12, the most stable isotope of carbon. When the mass of this most stable isotope of carbon was measured by an instrument known as spectrometer, mass spectrometer. So when the mass of carbon was measured by this instrument, the 12 gram of the most stable isotope of carbon were found to contain 6.02 into 10 to the power 23 atoms. That means the mass of carbon is measured as 12 gram, that is gram atomic mass. So the gram atomic mass of carbon was measured as 12 gram. So these 12 gram were found to contain 6.02 into 10 to the power 23 atoms that we define as 1 gram atom. So 1 gram atom contains Avogadro number, that is 6.02 into 10 to the power 23. So since 12 gram of carbon 12 contains 6.02 into 10 to the power 23 atoms were considered as 1 gram atom. So that quantity presenting 12 gram of carbon 12 is taken as a reference. So this mole is defined as amount of substance, any substance means this chemical substance, amount of chemical substance that contains as many entities or as many particles that were present in 12 gram of carbon 12 isotope. That is, when we define this term, so this term mole is defined as the quantity of a chemical substance that contains as many entities or particles that were containing 12 gram of carbon 12 isotope. So 12 gram of carbon 12 isotope contains how many atoms? 6.02 into 10 to the power 23 atoms. So this is how we define the term mole. So definition of mole is amount of a chemical substance that contains as many entities or particles that contains as many entities or particles as were present in 12 gram of carbon 12 isotope. So 12, as I have discussed, 12 gram of the most stable isotope of carbon, that is carbon 12, contains how many atoms? 6.02 into 10 to the power 23 atoms. So any chemical substance, any substance that contains that much amount is what we call as mole. So we have a term mole, which is basically a unit for measuring the amount of chemical substance, and this mole has relationship with atomic mass scale, that is carbon 12 scale, and when this mass of carbon 12 was measured to be 12 gram, that is gram atomic mass of carbon, by mass spectrometer, these 12 gram were found to contain 1 Avogadro number of atoms. So any particular substance that contains as many entities as were present in 12 gram of carbon 12 isotope, this is defined as mole. So look at this, we have this mole. So mole, the term 1 mole has got always a fixed quantity. So 1 mole is equals to 6.02 into 10 to the power 23. It may be atoms, it may be molecules, it may be ions, it may be electrons, it may be protons, it may be nucleons. So whatever may be the chemical entity, 1 mole has got a fixed value, that is 6.02 into 10 to the power 23 particles. So these 1 mole containing 6.02 into 10 to the power 23 particles These particles were also known as Avogadro number of particles. So these were used in defining atomic mass or molecular mass. So 1 gram atom. So 1 gram atom were found to contain Avogadro number of particles. So quantity having Avogadro number of particles is defined by another term which is known as mole. So whenever we talk of 1 mole, the number of particles present is always a fixed. And these particles 6.02 into 10.23, that was defined as 1 gram atom. Means 1 gram atom contains how many atoms? 6.02 into 10 to the power 23 atoms. So the mass of 1 gram atom, that is mass of 6.02 into 10 to the power 23 atoms, was defined as gram atomic mass. So 1 gram atom is nothing but 1 mole, and mass of 1 mole atom is called gram atomic mass. Similarly, when defining the molecular mass, we define the molecular mass or the molar mass or the gram molar mass, that was defined as mass of 6.02 into 10 to the power 23 molecules measured in terms of gram unit. So 1 gram molecule also means how many molecules? 6.02 into 10 to the power 23 molecules. So this is the term mole. So when I say 1 mole, the quantity is always fixed. So by different names, this is also defined as 1 mole is 1 mole atom is 1 gram atom, 1 mole molecule is 1 gram molecule. Now look at this. When I say 1 mole atom, so these contains Avogadro number 6.02 into 10 to the power 23 atoms. When I say 1 mole electron, so it also means Avogadro number was 6.02 into 10 to the power 23 electrons. When I say 1 mole proton, it also means Avogadro number of protons. When I say 1 mole molecules of it is suppose H2O. So 1 mole molecules of H2O means how many molecules of H2O? Avogadro number of molecules. When I say 1 mole cations or anions. So 1 mole cations or anions also means Avogadro number of 6.02 into 10 to the power 23 cations or anions. So whatever may be the chemical species, 1 mole has got a fixed quantity, and that fixed quantity is known as Avogadro number, which is given in honor of the scientist Avogadro. And the quantity is 6.02 into 10 to the power 23. In that it may be atoms, it may be molecules, it may be ions, it may be protons, it may be neutrons, or it may be nucleons, or it may be neutrons, etc. So 1 mole is always a fixed quantity. So this is the quantity known as 1 mole. How it is derived, where from it is derived, and how comes this value, that I am explaining. This is coming from mass spectrometer, where it measures the mass of 12 gram. It was found to contain 6.02 into 10 to the power 23. From there, this quantity is derived. So any quantity or any substance that contains these mass entities as well present in 12 gram of carbon 12 isotope, that is given as mole, and it is the concept of mole. Now, once we have defined this mole, the next question that comes to mind is how to calculate this moles, number of moles in any given chemical species. And what are the different methods, the different ways by which this quantity called as mole can be derived? So let's see calculation of number of moles. Number of moles. How to calculate number of moles? Now, for the calculation of this number of moles, we have a different ways by which number of moles in any given chemical entity can be find out. Now let's discuss one by one. Number of moles can also be defined if the quantity in terms of the mass or weight of the substance is given. So in terms of mass. So if the masses of the substance are given, how we convert this mass into number of atoms, number of moles. So in terms of this mass, let's define this number of moles. Now this number of moles is given by this symbol small n. So small n represents number of moles of any given chemical species. So we define this number of moles n is defined as mass of the given substance, mass of the given substance. This mass is measured in terms of gram unit. So when I think mass of the given substance means this may be electron, proton, molecule, compound, whatever may be. This mass of the given substance divided by the gram atomic mass or gram molecular mass. So this must again be measured in terms of gram unit. So mass of any given substance divided by gram atomic mass or gram molecular mass. This ratio of mass is defined as term which is known as number of moles. So therefore look at this. Let the mass of given substance be small w and the gram atomic or gram molecular mass that is being given by capital M. So capital M represents gram atomic mass or gram molecular mass. W represents mass of the given substance. So we have a relationship. Number of moles is mass of a given substance divided by its gram atomic mass or gram molecular mass. So therefore look at this. This N number of moles is equals to mass divided by gram atomic mass. Now look at this. If suppose number of moles and the molecular mass is given, then also we can define what is the quantity of the substance in terms of mass. So therefore, mass of any given substance is equals to number of moles multiplied by its gram atomic or gram molecular mass. So this is how we use for conversion. From mass, we can define number of moles. If number of moles is given, then we can also convert into mass. So this is one of the ways by which we can define number of moles. So this is in terms of mass. Second is, in many of the problems, instead of giving this mass, questions may say a given sample contains some particles, 5 particles, 10 particles or 50 particles, then what is the number of moles equivalent to this particles? So in such type of problems, we cannot use the mass because mass is not identified. So what we have to use is number of particles present in the molecule sample. So we have to define this number of moles in terms of the number of particles. So second is in terms of number of particles. So in terms of this number of particles, these number of moles N is defined as actual number of particles present in a sample, means in a given sample of atom, molecular ions, how many particles are present, means how many atoms are present, how many molecules are present, how many ions are present. That is the number of particles. So these number of particles divided by Avogadro number. So actual number of particles present in a given sample of the substance divided by Avogadro number. This ratio is also defined as number of moles. So therefore look at this. If the number of particles are given, then we have to use this equation to find the number of moles. So let this number of particles in a given sample be represented by capital N and Avogadro number by Na. So this ratio, number of particles divided by Avogadro number, that is 6.02 into 10 to the power 23. That is also defined as number of moles. So therefore look at this. Number of moles is equal to number of particles divided by Avogadro number. So if number of moles is given, then also we can define how many particles are present. So therefore, number of particles present in any given sample is equal to number of moles into Avogadro number. So therefore look at this. This number of moles, particle by particle present in 1 mole, that is Avogadro number. So therefore actual number of particles given in any given sample is number of moles multiplied by Avogadro number. So let this be equation B. Now we have number of moles defined in terms of mass, number of moles defined in terms of particle. So both these represents number of moles. So therefore from equation A and B, these number of moles is equal to mass divided by molecular mass. So these must also be equal to number of particles divided by the Avogadro number of particles. So if suppose question says a given sample weighs some x gram, then how many particles are present in the x gram? Then also we can define. From the given mass we define n, and from this n we define n. So this is conversion of mass into number of particles and number of particles into mass by this relationship. So this is one way by which we can define number of particles, number of moles we present in a given sample containing some n number of particles. The third one is in terms of volume. In terms of volume occupied by the gas at standard temperature, pressure or normal temperature, pressure. We'll discuss what is STP and NTP later on. So in terms of volume occupied by the gas at STP, standard temperature, pressure or normal temperature, pressure. So when I use the volume occupied by the gas, so these calculation of moles should only be restricted to gases only. Only for gases. And this cannot be applied for solid as well as gas, solid and liquids, because this is specifically mentioned in terms of volume occupied by the gas, whereas this mole in terms of mass can be used for solid, liquid as well as gas. Mole in terms of particle can also be used for solid, liquid as well as gas, whereas moles that will be defined in terms of volume is specific only for gases, and you have to keep in mind that is the volume occupied by gas at this condition only. So in terms of this, number of moles is defined as volume occupied by the given gas at STP divided by molar volume at STP. So let the volume occupied by the gas at STP be molar volume at STP. So molar volume at STP means volume occupied by 1 mole of gas at STP. So this molar volume is volume occupied by 1 mole gas at STP. So this volume occupied by 1 mole of a gas and STP is always a fixed quantity, which is equals to 22.4 liter or 22,400 ml. So any gas which is known as ideal gas, 1 mole of ideal gas at STP always occupies a volume of 22.4 liter or 22,400 ml. This is always a fixed quantity which is represented by Vn. So therefore, this number of moles is equals to volume occupied by the gas STP divided by 22.4 liter. So from this we can define what is the actual volume occupied by the gas. So therefore, volume occupied by the gas at STP is equals to number of moles multiplied by 22.4 liter. So suppose this is only for gas volume divided by molar volume, that is 22.4 liter. That is in terms of number of particles. This is in terms of in terms of mass of the given substance. Let this be equation B. Suppose we have a gaseous substance, then number of moles can be defined in terms of mass, number of moles can be defined in terms of number of particles, number of moles can also be defined in terms of volume of the gas at STP. So combining all these equation for a gases, this number of moles is equals to volume divided by 22.4 liter, which is equals to W by gram molecular mass, which is equals to number of particles divided by Avogadro number of particles. So this gives you relationship between mass and volume. If volume at STP is given, then we can define mass. If volume at STP is given, then we can also define number of particles. And if number of particles is given, then also this is converted into volume occupied by the gas at STP. Or if mass is also given, then this mass, what is the volume occupied by that gas given mass at STP, you can use this expression. So this is specific only for gas. These two can be used for solid, liquid as well as gas. So these are the basic three by use of which we can define the number of moles in any given sample, whether we have mass, whether we have number of particles, or whether we have volume. So we can use this. Apart from this, in some of the questions, we can also define this mole in terms of pressure, volume and temperature also, and this is again specific only for gas molecules, again only for gas. Now we have an equation This is known as ideal gas equation. Ideal gas equation, which says pressure into volume is equals to number of moles of gas, gas constant R, temperature T. This is pressure, volume, number of moles. This is gas constant. This is temperature of given substance. If pressure, volume, temperature is given, then we can define this number of moles. N is equals to pressure into volume divided by gas constant R into temperature. If pressure, volume, temperature, gas constants are known, then we can define this number of moles contained in that given sample of gas whose pressure, volume, temperature at that instant is X some values. So ये इक्वेशन तभी यूज करेंगे इफ द वॉल्यूम प्रेशर एंड टेम्परेचर गैस मेंशन है क्वेश्चन में, देन वी कैन यूज दिस number of moles method to find. Okay. One that we often come across in solution, this is only for solutions. Solutions are defined in terms of their concentration that we'll discuss later on. So if suppose question says concentration is given, volume is given, then how we define this number of moles? Now number of moles is equal to molarity into volume. So volume must be taken in terms of liter. So if the concentration of the solution is given in terms of molarity and total volume of solution, liquid volume solution is given as some way, then molarity into the volume of solution gives you the number of moles. Molarity we represent this by capital M, volume by V. So molarity into volume gives you number of moles. So therefore look at this, combining all these equations, what you get is if volume is given, we have this ratio. If mass is given, we have this ratio. If number of particles is given, we have this ratio. So we have this, therefore number of moles is equal to mass divided by molecular mass. To make a differentiation between these two M, we represent this by mm, molecular mass. This is equal to number of particles divided by Avogadro number. So this is equal to molarity into volume. If suppose we have to find the concentration, then concentration can be defined as number of moles divided by volume of solution measured in terms of liter. So this is how we convert from one term to another term by use of this definition. So this is the ways by which we can define or we can calculate number of moles of any given substance in terms of the quantities like mass, in terms of number of particles, in terms of volume occupied by the gas, or in terms of pressure, volume, temperature, or in terms of the concentration of solution. So this is how we calculate or how we define moles. So having gone through this, the concept of mole, how this mole is derived, what are the different ways by which number of moles present in a given sample can be calculated. Let's apply this equation in solving problems, because once I give you some problems, then it will be very much easier for you to understand how different formulas can be used to define the mole. So let me give you a simple example. question. You are given 34 gram of ammonia gas. Question says we have a sample of ammonia whose mass is 34 gram. Now in this 34 gram of ammonia gas, calculate number of moles of ammonia gas volume occupied by ammonia at STP. That means what is the volume occupied by 34 gram of ammonia at standard temperature and pressure. Number of ammonia molecules present in 34 gram. Number of atoms of nitrogen present. Number of atoms of hydrogen present in 34 gram of ammonia. Total number of atoms present in 34 gram of ammonia. How many atoms are present in 34 gram? Total number of electrons present. How many electrons are present in 34 gram of ammonia? So let's see how we can define these terms. So first of all, look at this. Mass is given. Molecule is defined as ammonia molecule. Formula is given. So we have to define number of moles from the given mass. So the approach of the question should be number of moles is equals to mass of a given substance divided by gram molecular mass. So mass is given, we have to define gram molecular mass. So molecular mass of ammonia is equal to mass of ammonia, that is 14. Gram atomic mass of ammonia is 14. Mass of hydrogen is 1. So this comes out to be 17 gram. So gram molecular mass of ammonia is mass of nitrogen, that is 14, plus mass of free hydrogen, that is 3. So the mass of ammonia gas is 17 gram. So we have this molecular mass. So therefore, number of moles of ammonia present in 34 gram of ammonia gas is 34 divided by 17. Gram will cancel out. So this comes out to be 2 moles. So therefore, see, 34 gram of ammonia corresponds to 2 moles of ammonia. So total number of moles of ammonia containing 34 gram of ammonia gas sample is 2 moles. So we have this number of moles to be 2. Second, let's volume occupied by gas, ammonia gas at standard temperature and pressure. That means we have this number of moles, 2 moles. Now we have defined this number of moles in terms of volume occupied by the gas at STP. So the approach of question should be, we have to define this number of moles in terms of volume at STP. So we have this equation. Number of moles is equal to volume occupied by the gas at STP divided by molar volume, that is 22.4 liter. So these number of moles we have find from mass, that is 2. Therefore, volume occupied by the gas means 34 gram ammonia City is equal to 22.4 into n liter. So 22.4 into number of moles n is 2. So this is 44.8 liter. That means 34 gram of ammonia at acidity will always occupy a volume of 44.8 liter. So this is volume. So again look at this, we have used a relationship. First we define number of moles in terms of mass ratio, then we define number of moles in terms of volume ratio. Since both represent same substance, so number of moles should be equal. So this is it. Next part of the question is number of ammonia molecules present. So question is number of molecules. So we have to define, look at this, number of moles in terms of number of molecules. So we have a relationship. Number of moles is defined as number of particles present in a given sample divided by Avogadro number of particles. So question is, the particle is molecules. Therefore, number of particles, that is number of molecules of ammonia, that is equals to number of moles into Avogadro number. Number of moles we have defined here 2. Avogadro number is always a fixed quantity, that is 6.02 into 10 to the power 23. So this is 12.04 into 10 to the power 23. So therefore look at this. 34 gram of ammonia contains how many ammonia molecules? 12.04 into 10 to the power 23 molecules of ammonia is present in 34 gram of ammonia. Also 1.204 into 10 to the power 24 molecules. Then we have look at this. How many atoms of nitrogen and hydrogen is present in 34 gram of ammonia? Now, take this 4, 5 and 6. I'll combine these two. Take this one molecule of ammonia. Look at this formula. One molecule of ammonia contains how many nitrogen? One atom. One nitrogen atom, 3 hydrogen atom. So single molecule of ammonia contains one nitrogen atom and 3 hydrogen atom. If one molecule contains one nitrogen and 3 hydrogen, then two molecules will contain 2 nitrogen and 6 hydrogen. 5 molecules will contain 5 nitrogen and 15 hydrogen atom. Now, actual number of moles present in 34 gram is 2. So obviously look at this. If one molecule contains one nitrogen, then 2 moles will contain, 1 mole will contain 1 mole nitrogen, 2 mole will contain 2 moles. So therefore, 2 mole ammonia contains how many nitrogen? 2 mole nitrogen atom. And how many moles of hydrogen? If one molecule contains 3 hydrogen, 1 mole will contain 3 mole hydrogen, 2 moles will contain 6 mole. Six mole hydrogen atom. One molecule contains one nitrogen, so 1 mole will contain 1 mole. One molecule contains 3 hydrogen, so 1 mole will contain 3 mole. Therefore, 2 moles will contain 6. So 1 mole means the Avogadro number. So 2 moles of ammonia, that is 34 gram of ammonia contains 2 into Avogadro number of nitrogen atoms. And how many hydrogen atoms? 6 mole. That is 6 into Avogadro number. This is the number of atoms of hydrogen and nitrogen. So convert this Avogadro number into 6.02 into 10 power 23, you get the value. Now, total number of atoms. So total atoms of nitrogen and hydrogen present in 34 gram of ammonia gas, it is 2 plus 6, that is 8 Avogadro number. So 8 into 6.02 into 10 to the power 23 atoms of hydrogen and nitrogen is present in 34 gram of ammonia sample. This is number of atoms present in 34 gram. Then we have total number of electrons present. Let's see how to define this number of electrons. Again, we have this formula, that is NH3. Look at this, we have one molecule of ammonia contains one nitrogen atom and 3 hydrogen atom. So one nitrogen atom, atomic number of nitrogen is 7. Now these atomic number is equal to number of electrons, or which is equal to number of protons. So one nitrogen is present in one molecule. So in this one nitrogen with atomic number 7, number of electrons present is 7. So these contains 7 electrons. So one atom of nitrogen contains 7 electrons, that is atomic number. One molecule of ammonia also contains 3 hydrogen atoms. Atomic number of hydrogen, that is 1. So number of electrons present in hydrogen is 1. Number of proton is also 1. So 1 hydrogen, 1 electron. But we have 3 hydrogen in 1 molecule. So number of electrons in 3 hydrogen is 3. So 1 molecule, 1 nitrogen, 7 electron. 1 molecule, 3 hydrogen, 3 electrons. So total electron is 10 electrons. So one molecule of ammonia contains 10 electrons. If one molecule contains 10, 2 molecules will have 20 electrons, 7 molecules will have 70 electrons, 1 mole will have how many electrons? 10 mole electrons. But 34 gram is equivalent to 2 mole. Therefore, 1 molecule contains 10 electrons. Therefore, 1 mole will have 1 mole the 10 mole electron. So 10 mole means 10 into Avogadro number. 2 mole will have 2 into, so this is 2 into 10 into 6.02 into 10 to the power 23. Total these electrons are present in 34 gram of ammonia. So this is how we convert from one quantity to another quantity. So once we define this number of moles, it's very easy to calculate other quantities, like what is the mass, what is the volume, how many particles are present, how many atoms are present, how many electrons are present, how many protons can also be defined. So once we have this number of electrons, which is also equal to number of protons, so we can also define total number of protons present in 34 gram of ammonia. Similarly, we can also define how many nucleons are present. Nucleons means number of protons plus number of neutrons. So ultimately, that comes into mind is whenever we use chemical calculation involving chemical substance, It's always better to convert this in terms of moles, and by use of these moles, we can convert from one unit to another, yeah, one term to another term. Now, let's take up some examples. Because this being a very new topic, more example is required to make it familiar. So, how to use this? Suppose question says A2Cr2O7 potassium dichromate is a compound potassium dichromate. Suppose this potassium dichromate quantity is given as number of moles is given as 1.5. So 1.5 moles of potassium dichromate is given. Question says how many atoms of number of moles of oxygen atom. How many moles of oxygen atom is present? Number of oxygen atoms present and total number of moles of atoms present and total number of atoms present in 1.5 mole. So let's see how we can find the values of this thing. So quantity of this potassium dichromate is given as 1.5. We are given 1.5 mole of this substance known as potassium dichromate. So in this 1.5 mole of potassium dichromate, how many moles of oxygen is present? And what is the actual number of atoms of oxygen present? How many moles of atoms is present here? And what is the total number of atoms present in potassium dichromate, whose quantity is defined as 1.5 mole? Therefore, first look at this. One molecule, single molecule, one molecule of A2Cr2O7 contains how many oxygen atoms? 7 O atoms. This also contains 2 chromium atoms. This also contains 2 potassium atom. Single molecule of this potassium dichromate contains 7 oxygen atom, 2 chromium atom and 2 potassium atoms. So total number of atoms present in single molecule of potassium dichromate is 11 atoms is present. Now the question is number of moles of oxygen atom. So if one molecule contains 7 oxygen, so if one molecule of dichromate contains 7 oxygen atom, then 1 mole A2Cr2O7 will contain how many oxygen atom? If one molecule contains 7 oxygen, so 1 mole will contain 7 mole oxygen atom. One molecule contains 2 chromium, so 1 mole will contain 2 mole chromium atom. One molecule contains 2 potassium atom, so 1 mole will contain 2 mole potassium. So 1 mole contains how many moles of atom? 11 mole atom. But question says 1.5. So if 1 mole contains this value, then 1.5 mole K2Cr2O7 will contain how many oxygen? 7 into 1.5 mole oxygen. How many chromium? 2 into 1.5 mole chromium. How many potassium? 2 into 1.5 mole potassium. So look at this. One molecule contains 7 oxygen. So 1 mole will contain 7 mole. If 1 mole contains 7 mole, then 1.5 will contain 7 into 1.5 mole. So therefore look at this. Total number of moles of oxygen is 7 into 1.5. 7 5 is 35, 7 1 is 7, 10. Mole. So 1.5 mole of potassium dichromate contains 10.05 mole of oxygen atom. So if 10.5 mole oxygen atoms, so how many atoms are present? 10.05 into Avogadro number of atoms. So this is equals to 10.5 into Avogadro number atoms. So total number of moles of oxygen is 10.5. Total number of atoms of oxygen is 10.5 into Avogadro number. Total number of moles of oxygen. So this is number of moles of oxygen. Number of moles of chromium is 3. Number of moles of potassium is 3. So total mole is 16.5 mole. So total number of moles of atoms present in 1.5 mole is 16.5 moles of atoms are present. If total number of moles of atom is 16.5, then total number of atoms is 16.5 into Avogadro. So therefore total moles of atoms is equals to 16.5 mole. That is number 3. Number 4, total atoms present is 16.5 into Avogadro number. That is 16.5 into 6.02 into 10 to the power 23 atoms are present. So this is how we define total number of atoms, total number of moles of atoms in any given sample. Now I'll give you some other examples. So how to use this number of moles or calculation of number of moles. Suppose we have this question. 1.5 into 10 to the power 22 atoms of an unknown element X. We have X element. This X element contains how many atoms? 1.5 into 10 to the power 22 atoms are present. Then we have to find number of moles of X. Then second, from this number of moles, if find the molecular mass, gram molecular mass of X, if 1.5 into 10 to the power 23 atoms weighs suppose some 15 milligram. Weight of 1.5 into 10 to the power 23 atom weighs 15 milligram. Then what is the molecular mass of the substance? So first of all, look at this. Number of particles are given. Therefore, if we find number of moles, so therefore, first look at this. Number of moles is defined as number of particles present in the sample divided by Avogadro number. So therefore, look at this. Number of particles is 1.5 into 10 to the power 22. Avogadro number is 6.02 into 10 to the power 23. So this is the number of particles. So 1.5 divided by 6.0 into 10 to the power minus 1. So this is the number of moles corresponding to 1.5 into 10 power minus 22 atoms of element X. Now second question says, if 1.5 into 10 power 22 atom weighs 15 milligram, then what is the molecular mass of this? So weight of 1.5 atoms is, so 1.5 into 10 power 22 atoms is 15. Molecular mass is defined as mass of one Avogadro number of atoms measured in terms of gram unit. So look at this, 1.5 into 10 to the power 22 atom weighs 15 milligram. Then one atom will weigh 15 divided by 1.5 into 10 to the power 22. Then 6.02 into 10 to the power 23. That is one Avogadro number of atoms will weigh 15 into 6.02 into 10 to the power 23 divided by 1.5 into 10 to the power 22. So therefore look at this. Mass corresponding to 6.02 into 10 to the power 23 atom. This is particle is gram atomic mass. So this must be in terms of gram. So therefore look at this. This will cancel out. 23 will cancel out. So therefore 6.02 into 10 power minus 3. So this is how we convert this mass of certain atoms into molecular mass. So molecular mass, so I'm repeating this. This is molecular mass is mass of 1 gram molecule. Atomic mass is one mass of 1 gram atom. So 1 gram atom is 6.02 into 10 to the power 23. So mass corresponding to 6.02 into 10 to the power 23 atoms or molecules. This is defined as gram atomic mass or gram molecular mass. So if the mass of certain atoms is given to you, then we can easily define what is the molecular mass or what is the gram atomic mass of the given unknown substance. Okay. So all this what we require is you have to know the basic idea regarding this mole, how this mole is defined, how many particles are present in the mole, and how we can define mole in terms of number of particles, in terms of volume, in terms of mass. And one more example that I'm going to discuss here is we have defined number of moles in terms of volume occupied by the gas at STP. Then, if suppose an unknown gas occupies a volume of 5.6 liters at STP, an unknown gas occupies a volume of 5.6 liter at STP. So these 5.6 liter of STP that is being occupied by this unknown gas, calculate the number of moles of gas present in 5.6 liter of unknown gas that is occupied by the gas at STP. So we have this number of moles is defined as volume occupied by the gas at STP divided by molar volume. So volume occupied by the gas is 5.6, molar volume is 22.4. So liter we cancel out. This comes out to be 1 foot. So 5.6 liter of the gas at STP corresponds to 0.25 mole of the gas. So whether we have number of moles or whether we have the volume, one can easily convert from one term to another term. So this is how we use the concept of mole and how to define the terms mole. So hopefully these brief discussions we can easily say how volume can be related to number of moles, how mass can be related to number of moles, how number of particles can be related to number of moles, and their interconversion, and by use of these moles how we can derive other quantities. So for this, the very important condition is we should know what is mole and what is the significance of mole. So for today we'll conclude here. This is about mole.